Here we go. All right, so we are on 2.1D, absolute value. In composition. So first thing we're gonna do is we're gonna do a quick review of how to graph functions. Okay. So how to graph functions. So if we have here, hold on. So here we have P of X equals, so I would like for you to write P of X equals 1/2 X minus 3. And then I would like for you to take a moment and graph it on your graph paper. So you got graph paper and you're going to graph P of X equals 1/2 X minus 3. And I would like to believe that we all know how to graph. Right now, do this, please. Take your notes. So you're graphing a line. Where do we start when we graph a line?
On line.
The y-intercept. We start at the y-intercept.
We need to go up to 9.
I did. You can go further.
Like, is it 8 to this part?
It goes -8 to 8 on my domain, and then roughly -9 to 9 on my range. Are you ready?
Yeah.
All right. So I'm gonna draw mine quickly. You should have had plenty of time to draw yours. So I'm gonna start with my y-intercept. Algebra 101. I'm gonna go to -3. My slope is 1/2. So I rise, run, and run 2. Rise 1, run 2, rise 1, run 2, rise 1. And I'm gonna repeat. I'm gonna fall, crawl, fall, crawl, fall, crawl, fall, and crawl. All right, I'm gonna do my very best to pretend that this is the straightest line you've ever seen. Create imagination. All right. Beautiful. I know. You're so proud of it. I tried. All right, thank you. Thank you. Okay. All right. So remember I told you in your do now that you need to get 2 colors ready. So hopefully you have your 2 colors. Now we're talking about absolute values and compositions. So we're gonna write down h of x, and for the entirety of our notes, we're gonna let h of x equal whatever color you want.
Oh, but we don't do it.
Just another color or pen.
Oh, we're just doing this on color.
No, you just need 2 different things.
So I write 8 times in the color. If we wrote the P of X in pencil, and we write the H of X in the other.
Yes.
Okay.
I'm confused. All right. H of X is going to equal absolute value of X. Okay. What does absolute value do? It turns your input. It makes the input. The output is going to be what? Positive, right? If my input is negative, then my output's going to be positive, because absolute value is not a, it's your measurement of distance, right? And so distance, even if I walk backwards, I didn't walk backwards, and I'm not gonna say, oh, -3 feet. No, I'm just a person who walked backwards 3 feet, okay? Distance is gonna always be positive, okay? So we're gonna talk about how does that affect our graph and our life here. So absolute value, the absolute value function is here. Now, we're gonna find H composed of P of X, which means that we're gonna take H and we're gonna substitute in P of X. Do y'all remember composition from last week?
Yes.
So we wrote H composed of P of X, which means that I'm taking P of X and I'm substituting it into H, which means that wherever, what is the value of P of X? Well, P of X equals 1/2 X minus 3. Okay, so that means inside of my function is now going to become the absolute value of 1/2 X minus 3. Absolute values. Yes, goalposts are absolute value. All right, so when we talk about absolute values, we're going to go through and simulate plugging in these values. So if I start here at -8 and I plug -8 into here, so all we're going to do is we're going to do it out loud. Are y'all okay with doing a little mental math?
Yes.
All right, so we're going to start with -8. Currently, -8 is what? -7, right? All right, so currently at -8, I'm at -7. That's for P of X. This is my P of X. Now we're doing the composition. So if I plug -8 into here, okay, what's half of -8? -4. -4 minus 3 is -7. What does the absolute values do to the -7? It's going to make it into a +7. Yes, we're still, see, notice how I'm still on purple? Okay. So let's try another one. We're going to go here at -6. It's at -6. Do we see that? Yes, you're still with me? Yeah? Okay. Now, if I plug -6 in to here for X, what is half of -6? -3. What is -3 minus 3? -6. What is the absolute value of -6? +6. So what do you notice is happening to these values? What is the absolute value causing my negatives to do? They're flipping, they're changing their signs, right? My output's going from a negative to a positive. So what do you think will happen at -4 or -5? It's going to be -4, +5, right? And then at -2, I'm at -4. It's going to become -2, +4. At 0, I'm at -3. It's going to become +3. At +2, I'm at -2. It's going to become +2. At 4, I'm at -1. It's going to become +1, right? Do we see how the output values are becoming positive? So when we get here, it's 0. Well, aren't these values already positive? So are they going to change? No, they're already positive. So our new graph would be from here to here. And then we go up because we already have our positive values. It still crosses over. Because if I plugged in 6, I'm still going to get 3 minus 3, which is 0. If I plug in 8, I'm going to get 4 minus 3, which is 1, which is where it's already at, right? I already have those positive values. So when you're taking the absolute value of a whole function, the conclusion is, what does absolute value do? Changes negative y's to positive y's, right? It changed my negative outputs into positive outputs. Do we see that? Is that okay? Do you think this is going to change if my function changes? No, it doesn't. No matter what the function is, even if it was just a squiggle line, the same thing is going to happen. Absolute value is going to take your negative y's and turn them into positive y's. But is it going to touch your positive y's? No, they're going to stay positive. You're already doing good. Keep doing good. Okay. All right. So we're going to do a non-linear example and go from there. Are we okay with doing a non-linear example? Okay. So we're going to do a quadratic. So you're going to write down q of x. So we've had p of x. Now we have q of x. And q of x equals x squared minus 2x minus 3.
You make a new one.
Yeah. A new graph. I don't know why you made yours so giant to begin with, but
It makes me understand it. better.
okay.
Because you told us to do 8, so I did 8.
No, yours is fine. James is really big. Oh, he just drew a box around it. That's why. All right. So we're going to talk about graphing this guy. So again, we're using the same 8x9 deal here. I have a quadratic. So a quadratic, what shape is this going to make? What is the shape called? A parabola. We're going to make a parabola. Parabola is what we're coming for, right? So that's the goal of our shape. In order to make a parabola, does anyone remember what you need to know? What can you always graph first from anything? The y-intercept. And what is the y-intercept here? It's -3. It's always the number without a constant, right? I mean, without a variable. It's called our constant. So it's going to be our constant. That's because if I plug in 0, what's going to be left standing? That -3. So we're going to graph our y-intercept. Okay. When you are graphing a quadratic, after that, you also need to know your vertex. Okay. How many of y'all remember that from Algebra 1 or in our class? The point, right? So your vertex, does anyone remember how to find the vertex? No.
It's the H of that.
It involves H. Exactly. It's your H and your K. Yes.
I don't know.
Okay. So the first thing we're going to do is find our vertex. Okay. To find our H, it equals -b divided by 2a.
Is that like step 1?
Mm-hmm. Well, step 1 technically was to graph the y-intercept, but
That's 2A, right?
yeah. So our vertex, remember, so A, B, C. So our B is what?
That's
-2.
negative.
Huh?
And the H equals like -b over 2A.
That's to find your vertex. Your vertex is H comp.
Equation we need to know. Or we didn't find that right here. Right?
Yes, it's a recall from Algebra 1, which it's okay if we don't recall. That's why we're taking notes, right? Yeah, it's okay. It's all right. H equals -b over 2a. So when you have a quadratic, you have your A, your B, and your C. So we're going to plug it in. So we have negative. Our B is -2 over 2. And our A is, if Casper the friendly 1. Because if there's nothing there when multiplying, what is always there? A 1. All right. A negative times a negative is a positive. And 2 times 1 is 2. So what is our H? 1. Our H is 1. I have this feeling in my spirit that y'all probably just talked about it and then it did it in the calculator.
Yeah, probably.
Yeah, probably.
Oh, there's a button on the calculator where you can find the vertex.
That's why I said I have this feeling in my spirit that y'all probably just talked about it and then did it in the calculator.
I never heard H of K ever. It was just like, oh, there's a maximum.
Stop hurting my heart.
Yeah, she was also pregnant the whole year, so that and then she was gone.
No. I've been pregnant twice. So no excuse to shabby.
There's no.
There's no excuse to all right.
Pregnant.
All right, guys. We're recording. Let's focus. All right. So to find the K, you take what you got from your H and you're going to plug it into the equation. So to find our K, we're going to plug into Q, we're going to plug in 1. And if I'm substituting that in, that means all my X's become a a positive 1, right? So we have. Good.
Okay.
Yes, it went good. Thank you. 1 squared minus 2 times 1 minus 3. All right. What is 1 squared minus 2 times 1 minus 3, my friends?
A number.
Good call. Good call.
All right, wait.
What is the number?
A number that's gonna be placed on the graph.
-4. We got it. So that means that our vertex is at 1, comma, -4. It,
How come it in K equals Q like times 1, but then whenever we put the equal sign, it's like a bunch of.
it's K equals Q of 1, which means that I'm substituting it. Sorry, you're good. This is function notation, remember? So that means that I'm substituting this value in for X. So everywhere there X was, we turned it into a. Okay,
Miss, I'm not gonna lie, you probably gonna have
The
to dumb
equation.
it down for me.
okay.
So K just equals the equation with the 1.
So K, once you find your H, K equals whatever that H
Oh,
value
K
with,
equals the H value.
after you find the value.
Equations.
Mhm.
Okay.
Yes. All right, so now we have our vertex and now we can reflect because we have to make a parabola, right? And
Yeah.
parabolas
That's
are
supposed to be there?
symmetrical. Yeah. All right,
Since we plot 1 negative,
now we have our
wait, why are there 3 of them?
parabola.
How did you get 3 of them? Oh, because
Parabolas are symmetrical. So if I know one, then I know the,
You did 1 negative 4, I had to intercept first.
we already had the y-intercept, remember? That was the first thing we did. We plotted our y-intercept,
Which is -3.
which is -3.
And then mirror.
We found our vertex and we're gonna mirror it over the vertex. Because parabolas are
Oh, that makes-
symmetrical. Do we remember that?
I'm
Okay.
trying to understand this algorithm, but all of this is confusing.
Tutorials. See it, look. All right. Okay, so bring your food. All right, here we go. That's the graph. That's all we've done. And again, I'm sorry. I know that this is an algebra skill that may not be present, but I can't keep teaching algebra and algebra 2 at the same time and us keep up with our pace. Okay, so if you're lost here, please, please, please make time for tutorials, try Khan Academy, but you're gonna have to do some part as far as us being in algebra 2, okay? All right, now, again, we said we're gonna let h of x equal absolute value of x. So if I'm gonna compose these, so if I'm gonna find the composition of h composed of q of x, that's gonna equal the absolute value of x squared minus 2x minus 3. And what did we just say in example 1 that means is gonna happen?
There's one positive.
Everything that is negative is gonna become a
Positive.
positive. So anything that's already positive, is it gonna change? So this right here, is this piece gonna, oh, that's horrible. I did not even trace it at all. Oh, no, no. Oh, no. I know, my parabola. Okay, let's try that again.
That's the parabola.
You know,
Okay.
it's better whenever you read it.
Thank you. I'll take that. All right, there's my parabola. All right, so let's talk about it. Is this piece gonna change?
No.
No, because the y values are already positive. Agreed? All right, but all of these are gonna have to do what?
Flip.
They're gonna change their sign. Does that make sense? Because these are currently what? Negative, and what does absolute value do?
Flip it.
It makes them positive. So instead of a -3, I'm at a
Positive.
+3. Instead of at -4, I'm at, instead of -3, I'm at +3. So now my graph is doing, and then this is not going to change. So it kind of looks like a W. So I took all that was negative and I turned it into a
All the.
positive. Do we
So
see
it's
that?
One, so the vertex will be like, 1, 4, basically.
The vertex?
Will be the new vertex will be 1, 4, right?
I mean, yeah, in that sense, yeah.
I feel really dumb.
Okay. All right, so we will finish these notes tomorrow and then you'll have an activity, okay?
I feel really dumb on it. Yes, can I keep this paper in here? Cause if
It is
not,
yours
it's
to
gonna
keep.
Get lost.